Hello, Science 10, and welcome to Lesson 5 on graphically finding work. So today we are going to be talking about how to find work on a system while using a graph. This is quite useful because what we've been doing, work equals force times distance, it's really just one uniform motion in the movement of one direction. This allows us to look at a system overall and figure out how much work is being done overall as a system changes direction or force changes. So it's very helpful. But in order to do that, we first have to talk about finding the area of two specific shapes. The first shape here is the rectangle. And as a reminder, in order to find area of a rectangle, you need to take the base and multiply it to the height. All right. So if you have the formula A equals BH, B and H beside each other just means being multiplied. So if you see something like that, or if you saw a dot in between the B and H, that just means multiplication. But that is the formula for finding area of a rectangle. It's also useful for area of a square, just so you know. The other shape that we need to find is finding area of a triangle. So this one is a little bit different because if we took a triangle and put it inside a rectangle, it's kind of half of a rectangle. So what we do is we use a very similar formula, base times height, but because it's not a full rectangle, we divide it by 2. So area equals base times height divided by 2. Now what you'll notice is in this formula, you'll notice that the very top is um, in brackets, okay, base times height. The reason why base and height are in brackets is because in order for this to function properly, you need to make sure that you multiply those two numbers together before you divide by 2. And making sure that you have brackets around them makes sure that those two get multiplied together first, and then the number that is the product of it gets divided by 2. If you just put it into your calculator like 2 times 4 divided by 2, you're not going to get the right answer. Okay, so make sure that you use your brackets. Another way you can look at it is when you divide by 2, you're really multiplying by 1/2. So if you're thinking, oh, I'm never going to remember that, you could also try area of a triangle is half of base times height. I'm going to be using the first one, base times height divided by 2, throughout the lesson. But if you are more comfortable with area equals half of base times height, you can use that. So let's start by looking at our examples. So I talked about how recently we've been talking about work in one direction, because remember it's parallel. Force has to be in the same direction, whether it's forward or back as the motion's movement. So what we're going to do is we're going to start really simple. We're going to look at this graph right here. So if you have a child lifting a stack of bricks at 1.5 meters with the force indicated on the graph, you want to calculate the work. But looking at this graph, you're probably like, how do I use this graph? So the first step when you are graphing work or trying to solve work using a graph is you need to start by figuring out the shape of the graph. So since this is a flat line, okay, and it wouldn't make any sense to just randomly create a slope is a slanted line, we're going to start by making a rectangle. So what you're going to do is you're going to find your shape and shade it in. So here I'm going to shade my shape in. And then what you are going to do is you are going to use the numbers that are on your graph. So you'll notice we're going to solve this by going base times height. Now, when you're when you're solving for work graphically, please remember that all graphs have really important titles on the x-axis, which is this axis here, and the y-axis, which is this axis here. You'll notice that the y-axis is force in newtons, and the x-axis is change in position, or m. So really, we are just taking distance times force, or force times distance, but instead we're using base times height because we created a shape. So what we're going to do is we're going to solve for this by looking for how far is my base, it's 1.5, how high is my height, it's about 85, and I'm going to then go area equals base times height. I'm going to multiply them together and I get 127.5 joules. So far we're doing really good, except the 127.5 is not significant digits correct. Okay, so it's too many significant digits. If you look at the rest of our equation, we have two numbers, 85 and 1.5. So what we need to do is we need to take that we need to take that and we need to put it into proper significant digits by using scientific notation. And when you do that, you will end up with 1.3. Now, the reason I end up with 1.3 is because when I move the decimal over between the 1 and the 2, the number behind the 2 is a 7. So I have to round up as I eliminate the 7 and the 5. So now I have 1.3 times 10 to the 2 joules. The second example I want to go through is a one that looks a little something like this. So using this graph, we're going to calculate work. Again, figure out the shape that you are trying to look for. So again, this is a slanted line. We call this a slope. So if I look at it, I'm going to be able to make some sort of triangle. So there's my line and there's my line. So as you can see, I have a right angle triangle. So now what I want to do is I want to put in my formula for my triangle. So remember, base times height divided by 2. Again, when putting this into your calculator, use your brackets. So when I figure out my base, I'm looking at about 6 meters. When I'm looking at my height, I want to come over and it's about 15 newtons. Okay, I'm off. It should be more like 16, but that's my fault. Then what you want to do is you want to go 6 times your 15 first. Get an answer for that, or make sure it's in brackets, then divide it by 2. And you get about 90 joules. Again, this is significant digits correct because it's 6.0, it's 1, it's 15. I messed up. This should have been 16, but that's okay. You get the idea. So let's talk about how this is used overall. So this is more of a type of graph you are going to now see for graphing work. As you can see, there is something going on in which this system is doing work, but we need to figure out how it's doing work because you will notice that it's changing direction. It's accelerating, it's staying the same, it's decelerating. Those are just words we're going to learn later on. But essentially, we can see that there are different slopes, one that slants up, one that stays flat, and one that slants back down. So what we want to do is we need to make sure that we find all of the different shapes that are found within this graph. So if we go back, here's my original graph. I always want to start by finding the triangles. So here's a really big triangle right here. So I'm going to start by finding my triangles. Key part here, guys, is don't make little tiny shapes because you have to calculate every single shape's area. So try to make as big of a shape as possible by ensuring that you're covering all spaces. So here's my first triangle right here. As I look at it, I now have all of this space left to cover. So I can see this tip here and here. So there's another triangle. It leaves me with this long skinny space here and a little square here. So if I go back to this graph, you'll see these are the areas I made. A big triangle, a smaller triangle, a bigger rectangle, and a skinny rectangle. And what I've done to make this a little bit easier is I've asked you to calculate work in each one by breaking it into sections. So the first one is for moving from 0 meters to 5 meters. So make sure that when you're doing this, that you're checking what spaces you're moving, okay? So I'm moving 5 meters as my base, and I'm going up 6 meters. So I'm going to use my area equals base times height divided by 2. And I'm going to plug my numbers in, 5 times 6, again, in brackets, or go 5 times 6 equals, and then divide that number by 2. So 5 times 6 is 30, and we're going to divide that by 2 to get 15 joules. Again, that's my significant digits. These are 2 numbers. This is 2 numbers. From there, I want to move on to the next area, but you need to make sure you are very careful. When you are doing the next section, a lot of students make the mistake at saying, oh, this ends at 7, so I'm going to use a baseline of 7. But that is incorrect. The base from 0 to 5 is part of the triangle. So you need to start from where one side of the rectangle is and carry it over to the next. So really, I'm starting at the 5 and moving over 2 spaces to the 7. So when an object moves from 5 to 7. So that's base times height. So what I want to do is I want to go, guys, I made another mistake. This is horrible. Its area is equal to base times height. So I'm moving, oh no, we're good. 2 meters, okay, across. I just mixed up which way my numbers were. 2 meters across, and then you're going 6 newtons up. So here we go. Here's where it ends. So again, base times height, so you have 12 joules. All right. So again, how did I get this 2? I went 5, 6, 7. That's only 2 spaces. Now I'm going to calculate one of my spaces that is from 7 to 10. So again, 7 to 10 is just from here to here. I'm going to start with my triangle, and I'm going to say, okay, the base is from 7 to 10. That's only 3 spaces. 1, 2, 3. So please do not write 10 as your base. It is only 3 spaces. So my base is 3, and I'm starting from the corner of my triangle. I'm not going from the line down here. Okay, that's part of the rectangle. I'm starting where the triangle starts. So I'm starting at position 4, and I'm only moving up to position 6. So that's only 2 spaces. 1, 2. So what I want to do is now multiply those together. That gives me 6, divide it by 2, and that gives me 3 joules. I'm going to calculate this square last, which is base times height. Again, starting at 7 and ending at 10 is only 3 spaces. I'm going from 0 up to the corner of the rectangle, which is 4. So I'm going to use that as my height. And in the end, I get 12 joules. Now you're probably thinking, I did all this work for what reason? What is the point behind this? Well, essentially, this is a system that is showing us different areas of work and how work is being calculated. You can see that not all of them are the same. So what you need to do is if you want to know the overall amount that work is being done in the system, you have to take it and you need to take all of these numbers and you need to add them together. So my first area had 15 joules of work, my second area had 12 joules of work, my third area had 13 joules of work, and my fourth area had 12 joules of work. You add it together, and our total becomes 42 joules of work. All right? That is how you solve a graph when it comes to showing how to do work. Now, I led you step by step through here's this section, here's this section. But what I want you guys to see and try is I want you to go back and redo the example we just did. But instead of making the shapes I made, I want you to try this and make different shapes. So rather than making two big triangle, a little triangle, a skinny rectangle, and a small square, can you make any other shapes? So then once you've made your new shapes, I want you to try and calculate work. So pause the video here, try it out, and see what your answer is. I'm going to do my example of the different shapes that I created. So looking at my graph, I'm going to do the big triangle again. Yeah, I know I said try not to do it, but I'm going to do it anyways. Why? Because it's easier. It's fun. It's a big triangle. It's the easiest thing. On that note, guys, you really can't get away from this triangle because you can't make a little triangle here. This doesn't make a shape. So the big triangle stays. I calculated this to be 15 joules of work. It was 5 times 6 divided by 2. So I got 15 joules for my triangle like you did before. This time, though, instead of making a tall, skinny rectangle, I've decided to make one large rectangle right here. So again, my area is base times height. So this time I'm going, instead of from 5 to 7, I'm going from 5 to 10. So my base is 5. And if I go up to the line that makes this beautiful rectangle, I go up 1, 2, 3, 4 spaces. So base times height is going to be 20. My area number 2 is 20. It leaves me with this space up here. Again, I really can't get away from making this triangle. So I said try not to do it, but I know you probably did. So this triangle right here and this little square here. So let's talk about this little square. This little square is base times height. Okay, so here is my overall 2 times 2 is 4. And then I'm going to do my triangle, which is base of 3, because remember, we're starting from the corner of the triangle, not where your line started. Corner of the triangle, 1, 2, 3, and it goes 2 up. Okay, so 3 times 2 is 6, but remember, we got to divide it by 2, so I end up with 3 joules. Now, my numbers look a little different than my last one. My last one was 15 plus 12 plus 3 plus 12. Okay, my numbers are a little bit different. My two triangles are the same, but my rectangles are a little bit different. But if I take these numbers and I add them up, okay, I get the same amount of energy. I still end up with 42 joules. So what I'm trying to get at, guys, is that when you're doing these, there's a bunch of different ways to create the shapes, but you need to make sure that you're creating full triangles first, and then you can create your little rectangles and squares. Again, try not to make way too many shapes because then you have to calculate 1,000 different examples of work. Instead, try to make as many big shapes as possible to keep it as simple as possible. So if you have any questions, please let me know. And again, we're just working with the formula of base times height for rectangles and base times height divided by 2 for triangles. I hope you have a great night, and I'll talk to you soon.